Hey you guys, this is Mr. Sal. This is just a quick lesson on factoring trinomials, which really turns out to be factoring by grouping anyways. So thanks for watching. Don't forget to like and subscribe and comment about the video below. Thank you. I guess this is kind of the basis of what we're going at right here. So factoring trinomials in this form, x squared plus bx plus c, that just means that the x squared has a coefficient of 1, which we don't usually show, right? So it's not there. We don't see it. What we really want to do is we want to take that c value, though. Of course, that'll be a number. And we want to find factor pairs now, not necessarily the factor tree. Okay? So if it was, for example, maybe this was 10, right? My factors would be 1 and 10, and maybe 2 and 5. Those would be factor pairs, because 1 times 10 is 10, and 2 times 5 is 10. But what I need these numbers to do is when I add them together, I need that to equal the b value. That's a question mark really right there, okay? So we're going to look at factor pairs of c until we find a pair that adds up to the value of b. So if b were 11, so if this was 11x squared, x squared plus 11x plus 10, then I know that my two values that I'm looking for, and we'll explain what to do with those here in a moment, the two values I'm looking for are 1 and 10. We do want to include negative factors. So for example, 10 would be -1 and -10. 10, sorry. And then -2 and -5. Because if I multiply these two negatives together, I still get the positive 10. And what that means is if instead of that being an 11x, maybe it was -7x. Okay, now the two numbers that I would need are the -2 and -5. What this does, finding these two, again, it leads into factoring by grouping, but it allows us to break the -7x up into two values that will then allow us to factor by grouping. Of course, you can just use the rule, which in this case means that one of them would be x minus 2, and then the other one would be x minus 5. So I'm just replacing these two numbers with two factors that we found right here. But there's a reason for that, and that is factoring by grouping, which I'm going to show you guys. So if you hate the rule, then you can factor by grouping. And that's one of the reasons I don't like this rule, is because it only works when the leading coefficient is 1. Outside of that, well, then we're always looking to factor by grouping anyways. Alright, so I'm going to avoid the rule on this one. We can do it on the next one, if that's what that example will do for us. So let's do it by factoring by grouping, alright? So once again, it's in this form, x squared plus bx plus c, which is extremely convenient. And I'm looking specifically at this 56 right here, right, which is our c value. So I'm going to break 56 up into factor pairs until I find one that where I add the two factors up, it gives me 15, which is the b value, okay? So 56 breaks up, you can do it with 1 and 56. Now, some of you guys know what it is already, and that's okay. I'm going to break it down up until we find it, which is unfortunately the last one. I've got 2 and 28. 3 is not factorable here, but 4 is. 4 and 14. 3, 5, 6 is no good. 7 and 8. Bam, nailed it. Now, it may take you some time to look at this, right? But which two of these, like if I add 1 and 56, does that give me 15? No, so that's no good. What about 2 plus 28? That's 30, not 15. 4 plus 14, we're getting closer, right? And then 7 plus 8, bam, that's the one that I need, 15 right there. Right, that's this middle value. What that does is it tells us what to break up that 15x into. So this is not factoring right here. I'm splitting that 15x up into two separate x terms. One of those will be 7x, and the other one will be 8x. Now that's a positive 8x and a positive 7x. The rest of it was x squared plus 56. See, what that process does is it makes it so when we do factor by grouping, it gives us automatic factors for the next set of factoring by grouping. Okay, well, just what we're used to, hopefully by now, is I've got this first set and I can factor out an x. So that gives me x plus 7 here. And then out of this set, I can factor out an 8, which would give me x plus 7. And from right here, I can factor out from both of these terms an x plus 7. And what am I left with? Yeah, x plus 8. Now remember, just for this form, oh man.
So would one be wrong?
End up with these two binomials. Let's see if it'll work. And we always start with x. X is in both of these. Again, it's only for this form. And then what two numbers did we have? We had the positive 7 and the positive 8, right? This is almost purely coincidental, just based on this form. Because once there is a different coefficient of x squared, then we've got to work it very differently. Now again, I like the factoring by grouping because it doesn't force us to memorize any rules like that. But if you like the rule, then memorize all the formulas you want. So that's a good point, actually. We should check, right? Now,
Oh wait, no, sorry.
some of you guys like
Never mind.
FOIL,
I'm tired.
No, you're. So let's go back and check, even though you guys don't want to. So I'm going to take x and multiply it by the parentheses, right? So I've got x times x plus 8. But then I've also got 7 times the parentheses, so plus 7 times the x plus 8, which is kind of just running this in reverse right now, right? And when I distribute the x, I get x squared plus 8x. And when I distribute the 7, I get 7x plus 56. See how it's all kind of coming back to the way it was? Oh, that's an x right there. And then I combine my x's, that's 15 of the x's, and then I still got the x squared and 56. So yeah, it checks off, which is good. You guys look at this one for a second and, think about this, right? I mean, what is our C value on this? Well, the C is 1. So I need to break 1 up into two factors that add up to 5. Well, what are factors of 1? 1 and 1. If you want -1 and -1.
-2 and 3. No, wait.
Now that would be the sum, right? But this one's multiplication. 1 times 1 is 1. So if I add these together, do I get 5? No, that's no good. What about -1 plus -1? Does that equal 5? No. Now it's -2. Well, this one can't be done. Does not exist. Now you may hate that initially, but I liked it. I liked it a lot. It is possible that on the homework they have like a multiple choice option for you to just click on that. Or maybe they have you write in not factorable, something like that. So my C value in this case, and I do need to be careful about that, it's a -18 this time, right? So if my C value is -18, I'm looking at values like 1 and -18, or -1 and 18, neither of which work anyways. Or I could do 2 and -9, but I could also do -2 and +9. Well, let's continue just to say that we didn't notice anything. I could use, yeah, right, I know you guys like that. So 3 times -6 would work, but -3 times +6 would work. That's as far as we can go anyways. So let's check these. Does 1 plus -18 equal this -7? No. What about -1 plus 18? No. 2 plus -9? Yes. That's it. Right there. So, again, really what this does is it tells us what to break up the -7 z's into. It breaks up into 2 z's, and negative 9 z's. You brought that up. So even though they look interchangeable, the negative 2 and 9 would add up to a positive 7, which is a huge deal. Okay, because I need it to be a negative 7 right there. Just specifically because of the factoring by grouping. So on this one now, I can start grouping these. From these two terms, I can factor out a z, which would give me z plus 2. And the second set, though, remember that negative stuff, right? So I'm actually going to make that plus this set of parentheses, but it's now negative 9z plus, I'm sorry, minus 18. And from there, it appears that I could factor out a negative 9, which would leave me with z plus 2. Again, this may have been helpful for us to see this set of parentheses right here, just so I can see what I need it to look like so that I can factor out that binomial. And now that I have them the same, I can factor these two out. So that would be z plus 2. And then in this other set of parentheses, we've got the z and the negative 9. That's it. Now again, remember that rule. I mean, the rule would have shown a positive 2 and a negative 9 here and here anyways, which is what we got. So we're in good shape. See, now we're looking to factor stuff, but now there's a coefficient for that x squared. Now it shows as the value a. Now all this, the only thing this changes if we use factoring by grouping, the only thing that changes is that to find our factors, we're not looking at just c, we're now looking at a times c. And whatever that is, I'm going to be looking at factor pairs of that and looking to see for the sum to be that b value. So it's only adding one extra value, not even a step really, kind of. Well, it is, it's adding multiplication. But the process is still essentially the same if we do the factoring by grouping. By the way, all that writing is just saying that same stuff. Just, I don't know if it's that nerdy, but yeah, it's still pretty nerdy. Dang it. This one's going to be a really good example because of the way it's going to end. And there is a kicker at the end. Kind of like an M. Shaman, what's his name? That guy. It's coming at the end, though, okay? So you got to wait for it. So on this one, let's just follow the procedure, right? I've got this as, what we want is ay squared plus by plus c, right? So maybe not as big a kicker at the end. Because all these terms have y's that we can factor out now, right? Which will then make this in that form. I want to factor out right now is the y, right? To make it that form. So, sorry, that was kind of a spoiler now. Dang it. So, no one likes those with those films. But we still have the 5y squared now, minus the 85y, plus now it's 360, right? So yeah, we're looking, we needed this form, though, to be ay squared plus by plus c. Now, before it was the x's. It doesn't matter if it's y's or x's here, okay? So, I'm just looking inside the parentheses. I'm going to ignore that y that's on the outside for now, okay? But what I want to do is break up that negative 85y into something, okay? Which means I do need to multiply 5 by 360 first. So I got 1800, so I need factor pairs of 1800 that would end up adding to negative 85. And right now, I mean, just to start off, you could do the 2 thing, but you're going to go a long ways on that. So I'm going to look at negative 18 and negative 100. That doesn't help. It's close. Like it's negative 118, right? So what else could we use? Maybe negative 200? And then what else would we have? A negative 900? 90. I think did I go farther away on that one? I got closer, negative 110. So I went from negative 118 to negative 110. So I need to get even closer.
It's 90.
All right, that's still pretty close. But we're not there yet, though, right? So let's try something else. All right, so multiplying these two gives us the positive 1800. But when I add the two, it gives me the negative 85, which is what we wanted, right?
Oh,
So now I know what I need to break up that negative 85y into. I got negative 40y's and negative 45y's. Some of you guys may be wondering even, like that negative 40y and the negative 45y, does it matter where we put them? No, it does not, because the factoring by grouping is going to take care of the rest of that stuff. So if you had those switched, not a big deal, okay? All it's going to change is what you factor out from the grouping. I know you guys are just on the edge of your seat for that stuff. All right, let's group these then. So I've got 5y squared minus 40y. I'm going to factor out from both of these a 5y, which leaves me with 5 minus 8 right there. And then let's factor out this other one. Again, I'm going to make that plus negative 45y plus 360. And I do need to factor out the negative because my leading term right there, the negative 45y, is negative. Right? I can make this just y, but now this will be minus. And 360, since we pulled out the negative 45, all that's left is that negative 8. Now remember, if you wanted to check, you could distribute that negative 45 back into the parentheses just to check. Well, from both of these, I've still got that y on the outside. I can factor out from both of these some kind of y minus 8 stuff, which I will do. 5 minus 8. And then what's left over? I've got 5y minus 45. And again, it's not necessary that we keep this other set of parentheses there. Now that looks good and it feels good because it took so long to do. However, we're not finished though, right? And that's where the 5 thing comes from, right? Yeah, right, that's that whole twist at the end. I can factor out a 5 from both of these two terms, which would leave me with y minus 9 right here. And then the 5 that I factor out, I'm just going to place it with the y. So I really got 5y times y minus 8 times y minus 9, and that would be it. This is pointing out what we just found out in that last one is if you can find a common factor in all three of the terms first to factor out, then do it. All right. So, like in that last example, if we had factored out a 5y first, then things would have been great because we would have had the original form, x squared plus bx plus c, which makes things pretty nice. All right. So if you can do that, if not, again, we already showed that it didn't matter as well. All right, so like this one. So we'll do this one a little bit different than that last one. We got 6x squared minus 26x plus 28. Here's the thing that we should recognize right away, is that all three of the numbers are even. So at least I should be able to factor out a 2. If I did that, then what would I be left with? 3x squared minus 13x plus 14. Now I'm looking at smaller numbers, which may be even easier to see if there's something that can be factored out of that, which there is not. Because, well, that's a negative 13, which would be prime. And it's not, well, 14 is not factorable by 3 as well. Whatever. In any case, I factored out a 2. And now I've got this other trinomial that I need to factor. So once again, we're looking at the a value and the c value just inside the parentheses, all right? The 2 really is not affecting anything now that we took it out. So I'm going to do 3 times 14, which is 42. And I need factors of 42 to add up to negative 13. Now since that's a negative 13, I'm going to be looking at the negative factors. Bam, there you go. Now we want those negatives, so negative 7 and negative 6. So I know I need to split up my negative 13x into a negative 7x and also a negative 6x. So this is what we're looking at now, which allows us now to factor by grouping. And in this first set, I'm looking to factor out an x. I don't see any other common factors, not with 3 and 7. So I've got 3x minus 7 left over there. And now we'll look into this other set. Again, I'll make that plus right there. And I'm looking to factor out on this one probably a negative 2, which would leave me with positive 3x and negative 7. Of course, that's in this big set of parentheses with the 2 in front. Good, we're very close. So I'm going to take this 3x minus 7 and factor it out. 3x minus 7. And then what do we have left over? I got the x and then the negative 2. And then in the front there I had that 2 as well. Just to be careful, I would maybe look at those a little bit deeper and see 3x and negative 7, nothing to factor out there. And then the x and then the negative 2, nothing to factor there. So I can feel pretty comfortable if I was not going to check my answer, even though I should. If I was taking a test, check your answers, dang it. But that works. That works. That's it. Just make sure we got this down. Here we go. 3, negative 5, and negative 4. I don't see any common factors for those. I mean, 3 and negative 5 are prime. And they're not even like 4. So we can't factor out anything. No greatest common factor for all 3 terms. So I'm just looking at my a value, 3, and my c value, which in this case is negative 4. So when I take a times c, 3 times negative 4, I get negative 12. Which makes things a little interesting, I think. And I need the 2 factors of this to add up to negative 5, right? So, what are my factors? I got negative 1 and 12, 1 and negative 12. I got negative 2 and 6, 2 and 6. Sorry, that's 2 and negative 6. 3 and negative 4, and negative 3 and 4. That's it. That's all of them. So, do any of these 6 add up to negative 5? Nope, they don't. So this one cannot be factored. Or it's prime, whatever. Alright, this one looks funky because we're not used to seeing like y squareds at the tail end of this thing. I mean, it's okay that we do, right? We're not so concerned about the letters when we're factoring by grouping, strictly the numbers. So on this one, just the same as usual. I mean, well, what the heck? Is there anything we can factor from these? 63 is 7 and 9, or 7 and 3 and 3, which does not match up with any 8 stuff, okay? So there's no common, greatest common factor to factor out from these 3 terms, which means we're going to jump right into A, 8, times 63. So 504 now, that's the product of A and C. And again, we're going to look at 2 factors of 504 that add up to negative 50. Now, since it is negative, I'm going to be specifically looking at only the negative factors of 504, which is positive. So, for example, maybe, I see it's divisible by 4. So maybe something like negative 4 and then negative 101. No, 1. Thank you, 126. Bam. That wasn't helpful, though. Because, you know, if we add those, it's not going to be negative 50. So let's try something else. Maybe negative 16. Well, I don't know if it's the answer, but negative 24 then what the heck? Well, I got is close. Negative 45, but it's not what we wanted, right? So yeah, and you guys may get a little frustrated with this, but there is some kind of guess and test on this stuff. Well, let's try something else then. All right, there we go. If I add those 2 together, then I get negative 50. So this tells us, once again, what to break up the negative 50 xy into. Now, we are keeping the xy's with these because if we combine them, we would need negative 50 of them. So I got negative 14 xy's and negative 36 xy's. Again, it wouldn't matter if you switch those. And I've got 8x squared with positive 63y squared, which now allows us to do this by grouping. Starting with 8x squared minus 14xy. And it looks like I could factor out a 2 from those and an x. Right? 8 is 2 times 2 times 2, or 2 times 4. And 14 is 2 times 7. So the 2's are in common. But what do I have left over? I've got a 4x and a negative 7y. Well, that's just the first part. Now we got to look at the negative 36xy plus 63x, I'm sorry, y squared, which I'm adding. And it appears that I need to factor out some kind of negative because my leading term here is negative 36. So what am I looking at? 9? 9 looks good. Because 36 would be 9 and 4. 63 is 9 and 7. So that's a good choice. I'm going to factor out a negative 9 from both of these. No, not just a negative 9, but the y as well, right? I can take out one of the y's with me. So I've got 4x plus 7y. Which is good. I mean, that's what we had in the red there as well.
Wait, minus 7.
Bam. That would have been bad if I missed that later. Well, I guess it would have been noticeable with the minus plus thing. But yes, thank you. We do want that to be minus 7y anyways, and because the math is right. So thank you. Well, now I can factor out from both of these terms a 4x minus 7y. And then I just have whatever's left in the other parentheses, the 2x and the negative 9y. Well, that's it. That's it for that one. This one's not too bad. No big numbers like 504 on this one, which is nice. But the process still remains. I've got my a value, which I need to multiply by the c. And 10 times negative 5 is negative 50. So I need two factors of negative 50 to add up to negative 23. I'm looking at negative 25 and positive 2. Which then allows me to break up that negative 23 into negative 25 xy's and a positive 2xy's. Well, factoring by grouping. So in this first group, I'm going to factor out a 5x, which leaves me with 2x minus 5y. And so the other set of grouping should produce the same binomial, right? And I can factor out from these two a y. It's a positive y. And I've got 2x minus 5y, which is what I wanted. And from here, I'm just going to factor out the 2x minus 5y. So 2x minus 5y. And then in the other set of parentheses is what was left, specifically the 5x plus the y. So on this one, we're going to do the greatest common factor on this one, which I kind of skipped it on those other ones. So let's just look at some factors on these. I guess we can look at the smallest one. 25 splits up into 5 and 5 only, which is nice. And 40 then would split up into 5 and 8. And negative 70 would be 5 and, well, you could say negative 14. Yeah. So we got the 5 that's common for all three of these, which we can then factor out. So what do we have that's left? 8x squared minus 14x plus 5. Is that easy or not? I don't know. But it does give us the greatest common factor to start out with. At least we're not dealing with a number that's humongous. So let's look at 8 times 5, which is 40. And we need two factors of 40 to add up to negative 14. I'm looking at negative 10 and negative 4, which was just kind of an easy factor pair. So I'm going to split the negative 14x up into negative 10x and negative 4x. All right, now the factoring by grouping. So So from this set, I can factor out a 2x, which leaves me with 4x minus 5. And that's in this big set of parentheses. From this negative 4x plus 5, I need to factor out a negative 1, which gives me positive 4x minus 5, which is what we wanted. Yeah, we got the 5 in the front. So now I've got the 5 in the front, but I've factored out this 4x minus 5 from both of those terms. And then all that was left is the 2x minus 1. And that will do it for this problem.